Forces. So a force is either a push or a pull. So I'm going to demonstrate that. If I have this little eraser, I can push it with my finger. I can also pull it with my finger. So anytime you push or pull something, we're applying a force to it. Forces can also be invisible. So if I hold this up and I let it go, well, it dropped. Why did it drop? Because the force of gravity pulled it down. A force is a vector quantity since it has both size and direction. So in the case where I just let this go, the direction was down. When I moved it to the right, the direction would be the right. If I pull it to the left, the direction would be left. So the scientific unit for force is something called the Newton. We use capital N, okay? And it's named after the famous English physicist Sir Isaac Newton. And a Newton is the same thing as saying a kilogram per meter squared. Forces are often measured by means of a spring scale calibrated in newtons. So we can hold up a scale and the units of that scale would actually be newtons. So force of gravity. It's an attractive force between any two bodies of mass. So that's interesting. So anything with mass actually does have a force of gravity or a force of attraction. So when I hold this eraser, it drops straight down instead of flying towards me. If I have gravity, the reason why it's not coming towards me is because the force of gravity of the Earth is so much greater. So the mass of the Earth is bigger, so it pulls it down. Gravity is important for large objects and can even act over long distances. For instance, we're affected by the moon's gravity in the form of tides. Okay, it actually pulls the water towards it. The formula for force of gravity, so the little g here just stands for force of gravity, is equal to the mass in kilograms times little g, which is the gravitational field constant. You also know it as the acceleration due to gravity, 9.8 meters per second squared. And I want to do an example showing exactly this. So the question says, what is the force of gravity on a 2-kilogram bag of sugar? First thing we need to do is write down the given information. Well, I'm looking for the force of gravity, so Fg question mark. The mass is 2 kilograms. And I do know one more piece of information. I know the gravitational field constant, little g. I know little g on Earth is 9.8 meters per second squared, down. Or I could change the units to newtons per kilogram. Both are totally fine. So first thing we do is we just write down our formula. Our formula is Fg is equal to mg. These are actually vector quantities. So what's our direction when we look at g? Well, gravity is always pulling everything down towards the center of the Earth. Okay, all we need to do is put in our information. So our mass is 2, g is 9.8, and when I punch that into my calculator, I simply just go 2 times 9.8, and I get 19.6. The unit for force is units, and the direction is down because we're talking about the force of gravity.